Edexcel Core Pure Calculus 4 Integration using partial fractions. Integrating with a denominator of the form ax plus b times cx plus d squared. As we've seen previously, it is often helpful to write an integral of an algebraic fraction in terms of its partial fractions. This means that the integral can then be split up into two or more separate, potentially easier integrals. In the case of a repeated factor, you may well end up with more than two integrals, and some of them will turn out to involve logarithms. So these are some of the features that we're going to be looking at in the next few slides. So here we've got the integral of x plus 15 over x minus 1 x plus 3 squared, which is a pretty tough integral to do. However, we have the advantage of knowing the partial fractions from a previous session for this can be written in terms of x minus 1, the linear x plus 3, and the repeated x plus 3 squared. And we found out that the numerators were 1, minus 1, and minus 3. So instead of integrating the original algebraic fraction, we can now integrate these three partial fractions with respect to x. Word of caution here, we often look at this first one and recognise that it's to do with logarithms, and this second one involves logarithms, but it's very tempting to think this third one involves logarithms, but it doesn't. If you think of it as 3 times x plus 3 to the minus 2, that will give you a better clue as to how it should be integrated. So now when we integrate term by term, we get ln modulus x minus 1 minus ln modulus x plus 3, and using this form of the fraction up here, we will get plus 3 x plus 3 to the minus 1. Now we can use our log laws to simplify this bit at the beginning, and we get the answer ln the modulus of x minus 1 divided by x plus 3, and we could tidy up this fraction a little bit as 3 divided by x plus 3 if preferred. So often with these integrals the process is going to be to set up the partial fractions first, noting the repeated factor and the linear factors for x plus 3. Being particularly careful with this fraction here, which should be written as 3 x plus 3 to the minus 2 before integrating, and if necessary be aware that using log laws to simplify the answer may be required. So when we're dealing with these problems, we should always have a check that the denominator has a higher power than the numerator, and if it doesn't, we might need to do algebraic long division or an appropriate method in order to achieve that. We can then split the algebraic fraction up into appropriate partial fractions, and the integral can then be split and handled as separate integrals. For repeated linear factors, you'll get both logarithmic and algebraic fractions after you've integrated, and the log can be combined as a single logarithm if required. That's assuming that the coefficients are relatively simple and not too complex to use. In the final session, we're going to be looking at integrating where the denominator has the form ax plus b times cx squared plus d.